Yes, so I'm going to talk to you different Earth observation data sets and some Copernicus products in developing services for coastal communities, fisheries managers, coastal managers, and so forth. My name is Kwame. I'm based at the University of Ghana, and we implement the GMES in Africa project in 18 countries, right from Nigeria up to Egypt. So we cover 18 countries in North and West Africa, and we are supported by 11 other partners based in Egypt, Tunisia, Senegal, Cote d'Ivoire, Ghana, Benin, and Nigeria. And the whole idea behind this project is to ensure that we take to the table of fisheries managers, coastal communities, environmental scientists, and even academic institutions, Earth observation data within coastal and ocean systems. The idea is to ensure that over the years, there is uptake of EO data products to solve the many environmental and coastal and maritime issues that we have within West and North Africa. The main purpose is to also feed into the African Union Agenda 2063 and Sustainable Development Goals. So within our project, we develop about 6 services from monitoring and forecasting ocean variables using model products from Mercator, using satellite observations, developing solutions for fisheries managers, that is developing potential fishing zone maps, analyzing vessel traffic data to detect illegal fishing. Then we also disseminate ocean states alerts to artisanal fishermen, and that is what Fabrice spoke to you about. And I'm going to talk to you about it in some details. Then we look at Sentinel-2 products to develop coastal vulnerability indices, map sensitive coastal ecosystems like mangroves, and process Sentinel-1 images to look at oil spills and so forth. So these are some of the products that we generate. At the end of the day, it should all fit into raising awareness on the relevance of geospatial information for improved livelihoods. So we use satellites to look at ocean variables. We track vessel activities to combat IUU. So the various images you see there are some of the data sets that we process to detect ships. We look at oil spill services for North Africa. This is developed by one of our partners in Egypt called Sidari. But we are also developing a platform that would allow us to process lots of Sentinel-1 imageries using optimized codes with Python to disseminate detections and oil spills, ship detections and oil spills that we detect from satellites. So one of the things that we also rely on most is the data from Mercator. So back in West Africa, and we are trying to also transfer some of the services to North Africa, where you have a strong artisanal fishing community. For example, in Ghana and in many other West African countries, there is a strong community of fishermen that rely on small, feeble boats or canoes to go to sea to get fish. But then at the end of the day, we want to ensure that these guys are constantly safe. Fishing is their livelihood. So how do we sort of take satellite data, take model products, which is very, very complex for the uneducated fisherman, but then how do you convert that into information that they can easily assimilate, that they can rely on and use to ensure that they can go find food on the table, support their families by selling the fish that they go to catch. So like Fabrice had indicated, we take model products from Mercator. It could be waves, currents. We look at elevation from altimeter data and so forth. And now we're even including rain products. So from UMETSAT, the idea is that we develop a lot of indices that is easily understandable that can be easily understood by the fisherman. So when we started the project, the idea was to communicate the services to fishermen. We were using USSDs, So it's an alert you send to a fisherman. But we realized that not all fishermen had access to phones. So we thought of using flags. So in the picture in the middle, you see this gentleman carrying flags that we hoist at the beach. So a community leader would receive the information and he would go mount the appropriate color. When you see green, it's safe to go to sea. Yellow, it's intermediate, a bit rough. Then red, very dangerous. And on your right, you can see the products that we disseminate via a phone, via USSD SMS. So a user calls into a number or a service, then he receives an alert and he's informed 3 days ahead of time whether it's safe to go to sea. So this service allows them to plan very, very well. We also support a lot of capacity building activities, from processing EO data, developing various services, engaging and non-technical people who need to understand the importance of Earth observation for resource management. And we are also now building expertise of coastal young people. I mean, guys who have not had advanced education, but we now teach them about sensors and to use Internet of Things to develop in-situ measuring devices that we can use. One of the interesting things we are also doing in collaboration with a company in the US, Ocean Data Network, is to put sensors on fishing nets. So in the picture in the middle, you see that yellow device. It's a sensor that is activated the moment it touches water, then it measures temperature. This is very useful for improving our models or validating the measurements we take from satellites and models. And you know, satellites often don't resolve very well in coastal systems. So this approach is very, very interesting, and it's something I need us to start thinking about, because going forward we can develop other sensors that we can deploy using canoes as crafts. So that is the end of my presentation, and you can always reach out to us via these handles. Thank you very much.
Thank you very much.